solving quadratic equations by completing the square. Now this is actually a quadratic function, right? When you have y equals, and that has a graph. And here's the graph, y equals x squared plus 10x plus 11, which has some points of interest, right? These are our points of interest, the x-intercepts of the graph. What we want is to solve the quadratic equation, and that equation is going to look like this. So it's not a graph, it's x squared plus 10x plus 11 equals 0. This is a quadratic equation, right? When we set a quadratic equal to 0, or rearrange it so that it is equal to 0. It's got a slightly different method of completing the square, and it's because it's equal to 0 that we can get away with that. What are some other sources you can look at? Certainly you can look in the textbook. This section, the questions, are on page 240. So if you look before page 240, you're going to see a number of examples of solving quadratic equations by completing the square. You can go to YouTube, type in solving quadratic equations by completing the square. There should be many videos on there besides this one. Khan Academy, the Khan Academy will have a video, I'm sure, on solving quadratic equations by completing the square. But seeing as you're here, let's do this. So I'm going to do a few of these. Let's start with this one. So the first step, since it's equal to 0, right, and what we would have done with the quadratic function is we would have completed the square to get it into vertex form, right, which is y equals a x minus p squared plus q. And if you remember some of the work we did on that, we would find x-intercepts, how we would set y equal to 0. We would move the q over, we would divide by a, we would square root both sides and solve, and that's kind of what we're going to do here. But since it's equal to 0, we can do this a little bit easier. So my first step in this, and this has a leading value, a value of 1, so that makes this just a little bit easier. Let's go x squared plus 10x. I'm going to leave some space and set that equal to negative 11. So in this case, I'm keeping the x squared and 10x on the left side, moving the number to the right side. That's our first step, is getting to this form. Now, completing the square. Well, we know how to do that. It'd be x. This sign is plus, so we've got plus. Half of 10 is 5. Quantity squared. Now, what did I just do? Well, I've got x plus 5 squared. Expanding that, I'll get x squared plus 10x plus 25. So I need to go up here and add 25. Well, to keep things equal, if I've added 25 to the left, I must add 25 to the right-hand side. The x squared plus 10x plus 25, that's this, x plus 5 quantity squared, and negative 11 plus 25 is 14. Okay, let's give ourselves a little space below here. So the next step is to take the square root of both sides. Square root of x plus 5 quantity squared is x plus 5. And this square root is plus or minus root 14. This side will always have a square root which is plus or minus. That's what's going to give us the two x-intercepts. See these two x-intercepts here? That's what's going to give us the two x-intercepts. And to finish it off, because we like exact values, x is negative 5 plus or minus root 14, which gives us two values. X is equal to negative 5 plus root 14, and x is equal to negative 5 minus root 14. And those are our two x-intercepts, right? Remember, we could have no x-intercepts. That would be the case if we ended up with a negative here, and I tried to take the square root of a negative. I'm not allowed to do that. Then there would be no x-intercepts. And we could have one x-intercept as well, and that would work out if this side were 0, and then the only x-intercept would be a negative 5 value, right? We would just have 0 on this side when we went to take the square root, which would give us a single x-intercept. And in this case, we have 2. Okay, we're going to come back and we'll do a couple more of these. If we don't want an exact value, if we need a decimal, you can just plug this into your calculator to work it out. And often remember that it depends on the context of the situation. Okay, here's another one. Negative 1/3 x squared minus 7x minus 17 is equal to 0. Quadratic equation means equal to 0. quadratic function is y equals. That gives us the graph. We're not interested in the graph. We're interested in the value or values of x, which when substituted in here will give us a 0. Now, nice thing, since this is a 0, we've got a negative 1/3 here. We can get rid of that negative 1/3. And the way I'm going to do it is multiply both sides of the equation by negative 3. Negative 3 times 1/3 is positive 1. So I'm going to try and end up, or I'm not going to try, I'm always going to end up with a positive 1x squared. Negative 3 times negative 1/3 is positive 1. Negative 3 times negative 7 is plus 21x. And negative 3 times negative 17 is plus 51. And negative 3 times 0, that's why all this works, is 0. Is the graph of this the same as the graph of this? No. But they do have the same x-intercepts, and that's all we're interested in finding. That's what allows us to go through and multiply by the negative 3 as long as we do it to both sides, and it's 0 that's the key. Okay, does this factor? Well, no, I'm not going to find two numbers that multiply to 51 and add up to 21, so we can't do it by factoring. So what's our method? Completing the square method. First step, isolate the x squared, and now it's always an x squared term, right? Because we can always make it that. Leave some space and move the constant to the right side where this is now negative 51. We've left some space here, and we're leaving some space here. Set of brackets. I need to find a binomial. I need to make a perfect square trinomial. I do that. X plus half of 21 is 21 halves squared. When you square this, you'll get x squared plus 21x plus 21 squared over 2 squared. So now I have to square 21. Okay, so 21 over 2 squared gives me plus 441 over 4. Since I've added that to the left side, I will do the same. I will just add 441 over 4 to the right-hand side as well. Let's simplify the right-hand side. Negative 51 will be negative 204 over 4 plus 441 over 4 simplifies to 237 over 4. Now we want to take the square root of both sides. The square root of something that's squared is just that something. So x plus 21 over 2. And this will be root 237. And the square root of 4 is 2. So it's root 237 over 2. This won't simplify. So we remember that this is plus or minus root 237 over 2. And it becomes negative 21 over 2 plus or minus the root of 237 over 2, which we would better off just writing this from the beginning as x equals negative 21 plus or minus the square root of 237. And make sure that's extended all the way across the root over 2. And that's our solution. We have two solutions here, negative 21 plus root 237 over 2, negative 21 minus root 237 over 2. Remembering that if we're working in a situation that has a context, we may need to reject one of the solutions, perhaps the negative one, depending on the scenario that we're looking at. Okay, one more. I'm going to start this in a slightly different form. This is 3x squared minus 19 is equal to 12x. Now, in order for us to solve, we have to have the x squared and the x term together, so minus 12x, and we want the constant on the right-hand side. All right, let's start. We're going to divide everything by 3, right? The idea is to get a 1x squared. So this is x squared minus 4x, leave some space, we'll need it, is equal to 19 over 3. So we've divided this by 3. Negative 12 divided by 3 is negative 4, and 19 divided by 3 is 19/3. Completed square form. It's a binomial. It's x minus half of 4 is 2 squared. 2 squared is 4, or negative 2 squared is 4. Add 4, add 4. This x squared minus 4x plus 4 is taken care of by the x minus 2 quantity squared. 4 is 12 thirds, and 12 thirds plus 19 thirds is 31 thirds. Square root both sides, plus or minus the root of 31 over 3. Everything stays under the radical here since 3 doesn't have a square root. And add 2 to both sides. 2 plus or minus the root of 31 over 3. And okay, we can't leave this with a radical in the denominator. 2 plus or minus, think of it as root 31 over root 3. We need to get rid of that. So if you remember, rationalizing the denominator, we're going to have to multiply by root 3 over root 3, giving me root 93 over 3. So this is x equals 2 plus or minus root 93 over 3. But wait a sec, we can put it all over 3. So 2 over 1, if I want that over 3, that's equal to 6 over 3. So ultimately, the final answer is 6 plus or minus root 93 all over 3. And that is our final answer. That's our